Welcome, everyone. It's fantastic to be here to talk about this critical topic about feedstocks for synthetic fibres. I'll invite everyone to introduce themselves properly in a moment. But before we do that, I just want to set the context a little bit for everyone. I'm Brooke Roberts-Islam. I'm a freelance journalist and consultant, and I'm here with an esteemed panel today of experts all working in next-gen feedstocks for a range of synthetic materials and protein-based materials. So to my immediate left, Simon Whitmarsh-Knight from Hyosung, Gudrun Vogtentanz, who's from Amsilk, Jerry Lowe from Leaf Bio, and then at the end, Bruno Marengo, who's from Fairbrics. So to bring us all up to speed just firstly, I had a lot of discussions with people at the conference yesterday, which was fabulous, but it was clear to me that this is a topic that's very poorly understood. It's very confusing. It's probably been blighted by some poor marketing and possibly even some poorer journalist coverage over the years as to what bio-based actually means. I want to make it clear to everyone that today we're having a discussion about ingredients. We're talking about feedstocks. We're talking about what goes in to make the synthetic fiber or material. We're not talking about what comes out. Bio-based in does not equal bio, plant, anything different out. This is a really important distinction. So today, most of our synthetic fabrics are made from fossil fuels, which contain carbon, hydrogen, and oxygen. We can get those elements from other places, including corn, sugarcane, textile waste, carbon emissions, food waste. I probably missed one, but I think that covers most of you. So what we're doing here is grabbing the necessary building blocks from somewhere other than a fossil fuel, synthesizing them with chemical processes and sometimes biological processes, and getting the usual output. Right, now we can get into it. I hope that makes everything a little bit clearer for everyone. But first of all, let's just have a quick couple of sentence introduction from each of you as to what your solution is and what makes it important and different.
Sure, thanks Brooke, thank you very much. Thanks everybody for coming as well. It's a hot day, it's kind of ironic, we're at a Sustainability Expo on one of the hottest days of the year. Thanks everyone for making the effort to come. I'm Simon from Hyosung. Hyosung's the largest manufacturer of spandex in the world, and what we're proud to showcase here is our bio-based spandex partly made from renewable materials, which in this case is sugarcane. Mm-hmm. And we're also super proud to help support other biosynthetic businesses by sponsoring the biosynthetic area a bit further up in the hall.
Fabulous. Gudrun.
So my name is Gudrun, I'm from Amsilk, and very similar, but we are using renewable feedstock to produce high-performance proteins. And then using precision fermentation, we engineer microorganisms to produce silk-inspired biomaterials. So we combine outstanding performance with full biodegradability. So that is our angle.
Yeah. Thank you. Jerry.
Thank you. Hello everyone, I'm Jerry from Leaf Bio, and we create a new material called Bioflix. And its chemical name is PEF, which is also very hard to understand, but it has three features. First one is 100% bio-based, which means it's fossil-free. And secondly, it's a performance material. It has stronger moisture than that of polyester, make it softer than polyester, and has an antibacterial property without any chemicals. And thirdly, it's a recyclable material. Which make it can be recycled by the equipment of polyester.
Okay, I want to make sure that I haven't set this up in a confusing manner, but just to be clear, the output differences are due to engineering and differences in the processing. That's correct, isn't it? It's not simply a matter of the bio input creates a different output.
Yeah,
it's additional processes and novelty.
Actually, it's a new process and to make a new material.
Okay, yeah, thank you. Bruno.
Hi everybody, I'm Bruno from Fairbrics. So at Fairbrics what we have been doing is working on CO2 valorization. for a couple of years now, and the first product we've been working on is polyester. So the mission is to do a carbon negative polyester. At the moment we are scaling up the CO2 to ethylene glycol part, the end result being a virgin polyester with a drastically reduced carbon footprint. So it's a pure drop-in solution, we just change the feedstock.
Super. Let's start with you, Simon, and dig into the Feedstocks journey of Hyosung a little bit. So you started out putting, I think it was 30% corn-based in with fossil-based ingredients to make, was it Creora years
That's
ago?
correct, yes, yeah.
And so that was a sort of first step on this Feedstocks journey. Since then, you've gone to a sort of full-scale fermentation plant in Vietnam to create BDO from sugarcane.
That's right.
So tell us, why sugarcane? Are you taking people's foodstuffs away, or what's going on?
Before we answer that question, first and foremost, in
Do
case
that.
the audience gets worried,
Do that.
obviously in terms of sugar, there's an overproduction of sugar in the world.
Okay.
There's a surplus which is already being used in other industries, like biofuels, for example. So, and we might talk about that as part of the conversation. You know, there's still a lot of education probably around sugarcane compared to maybe corn. But again, to reiterate, there's a surplus of sugar in the world. We're taking that from that surplus and we're using to partly make bio-based elastane from that. So maybe just to give some quick context, again, some of the people who are listening might not be familiar with Hyosung. As I mentioned, we're the largest elastane producer in the world. You know, we want to be net zero by 2050.
Mm-hmm.
So by a couple of years ago, looking at where the majority of our emissions were coming from, no surprise, 67% are from raw material processing.
Got it.
We already offer a more sustainable elastane in terms of a recycled version. That's using our own waste. But that's only
T to T.
it's pre-consumer, and that's the key difference, Brooke,
Yeah.
because there's always going to be a constraint with that supply, because it's only ever going to be 1% or less than 1% of our total sales, because it's our own waste.
Got it.
So really then thinking about how to lower our emissions over time, then looking at raw material supply, feedstock, that's the most significant lever that we could pull to help reduce emissions overall. So as you said, we started 3 or 4 years ago with corn. As Charles has said many times before, don't let sort of perfection stand in the way of progress. So it's really our aim. Again, today isn't about saying, gosh, this is a perfect product, we're all done, isn't this wonderful? It's not that at all, there is no perfect product, but it's really us trying to get better along the way. So we started with corn, technology improves, we're then able to think about new feedstocks, and at the moment that's sugar. And so we're taking sugar, as you say, we're fermenting that sugar to make bio-BDO, and all of that's in Vietnam. So once the sugar comes in from Brazil, everything else is made in Vietnam, which means you've got a very, it's effectively a low carbon integrated production system, which means it's also a shorter supply chain, so it's much faster lead time, which overall for our customers in the audience is great because it helps to lower carbon emissions.
Yeah, and in-country
Correct.
sort of
Correct.
lead time containment. But you're making BDO, aren't you? You're making a
Correct.
monomer
Yes.
in this process. So that has to be catalyzed with another ingredient to make the final polymer. So how do you know that the BDO part is the sort of the bigger footprint part? How do you know you're tackling the bit you should be?
Yeah, that's critical for us, and that's a significant part of the overall makeup of spandex, and BDO is actually
spandex,
or
not
spandex elastane. It's probably
Sorry.
elastane as we're in Europe, but
Sorry.
BDO, again, I'm sure the audience is aware, is a component that's used in lots of different industries,
Yeah.
so not just elastane.
Plastics.
So it's elastane, it's also in footwear, it's in packaging, it's in automotive interiors. So and we're the largest purchaser of BDO in the world because we're the biggest spandex manufacturer. So if we can, over time, move away from that fossil fuel-based BDO to a BDO that's a bio-BDO using a renewable feedstock, that's a huge reduction in carbon emissions. So it's a big part of spandex. We're also hoping to see that evolve in other industries. As you quite rightly said, we built the plant. We're at full scale. We can make 50,000 tons of bio-BDO this year. So really the question now is more a challenge to the industry. We've made it. We're hopefully a great example for other companies that are starting on that journey and that we're at scale. Now we really want to help the industry start to adopt and speed up the adoptions of that.
And I imagine you want to fill that capacity. pretty quickly.
We want to certainly do that, yes.
So Gudrun, let's talk about feedstocks with your business and the feedstock decision. What are the options you have and what's influencing the choices you're making?
So for us, it's very similar, and you are an inspiration to us. We start with sugar, and this is the feedstock we are using right now to really as a carbon source for our protein. And then if we talk textiles, the second step, it doesn't end with the silk protein. It has a spinning process to end up with the fiber. And right now for us, it's very important that we want to be European-based. Also, the production should stay in Europe. But we start out with glucose, so that is our C source for now. But we have a clear plan that we are developing to use food waste or sugar waste streams. But then the North Star is really CO2 or CO as a carbon source. But for now, and this is really due to we want to deliver quality fiber, and we can do it with sugar. So yeah, that's why it's.
And to be clear, when we say feedstock in this instance, it's the food for the organisms that grow the protein.
Right.
And so just so that everybody's clear on that, what happens once those organisms have grown the protein? What's the next step? And how does it become? Because it's not, again, I had a question yesterday, if something's a protein, can you make it like be a wool?
Yes, we can.
Can you help explain that?
So it's via fermentation using microorganisms, we end up with the silk protein, which is at the end, when we purify it and dry it, a white powder. And with that powder, the application, the sky is the limit, right? It doesn't need to be fiber, but then we can, with the spinning process that we are using, we can make staple fiber for wool, but our specialty is endless filaments. That,
that is. And if you weren't doing this, what would people use as an alternative fiber? Would it be an ordinary silk, or what's it most similar to?
So it's very similar to silk, and that's also the properties we want to reach.
Right.
But in theory, because we are using a protein, right? Not in theory, we are doing it already. We can engineer in functionalities.
Yeah.
So we can customize our protein, our fiber.
And I believe you've already worked with some brands. You're at a commercial scale. I think Balenciaga was the brand that you mentioned.
Yes, Balenciaga. Well, our first product is on the market through Balenciaga.
Okay.
And yeah.
Okay, and we're all probably wearing Hyosung, let's be honest.
I would hope so. Yes, yeah.
Jerry, could you tell us a little bit about the new PEF polymer that Leaf Bio has developed? And I think you can maybe also mention the different feedstock options you have as well, because you're quite flexible with that. If you can expand.
Actually, for our technology, the feedstock is similar to Amsilk. In the past, we use glucose, which is mainly coming from the food. And last year, we transformed the technology into use agri-waste. In China, the most easy way to get agri-waste is to get straw. So we're dealing with straw and to use enzyme to get cellulose from the straw and to make it into glucose. And then we get our monomer and polymer PEF. And for now, we are trying to upgrade our technology to dealing with the textile waste. Especially for the cellulose-based fiber, like waste cotton, waste clothes, or some other kinds of waste textiles. But in the process, we find it depends on the applications. Because in the past, we use PEF in the packaging industry, and at that time, it's okay to use glucose or agri-waste. But it's hard to use textile waste because there's lots of dyeing inside, cannot make the safety for the food contact. But now we find because of the T2T people need to deal with the blends, especially the blends with cotton and polyester. So we find the potential of use with the cotton in these solutions.
Okay, great. And could you talk just briefly about the cost considerations around the different feedstocks? Because when we were preparing, you were explaining that it's not simply a matter of which feedstocks are abundant or which feedstocks would brands like us use. It's about, does the cost associated with that actually work in terms of pricing? So could you maybe give us a little bit of an idea on how pricing's an issue for with feedstock choice?
Yeah, and I can just say the number first.
Okay.
Well, now the cost of use textile waste is almost, I think, more than 50% higher than that of use agri waste. I think that's mainly because, firstly, the feedstock is quite complex. There's many components inside, and your technology need to deal with lots of components, and you will get lots of side product, which is much cheaper than your product. And secondly, because the recycling of textile is quite, especially in China, is super new. Not many partners who are doing the things like in Europe. You even need to spend lots of money to buy the feedstock, and the cost of say feedstock itself is even much more expensive than that of glucose. So, so I think firstly you need to have lots of partners to dealing with the recycling, and secondly you need to upgrade your technology to deal with the component.
Could it also be that this is about maturation of that sector in terms of efficiencies? Because right now, I'd imagine that waste is better valorized through a mechanical recycling process or some other separation process rather than using it in your process. Is that a fair
Yes,
deduction?
I think the matter of the whole supply chain needs some patience. That's when you imagine it, you will find there's lots of potential. But when you do it, you will find there's a problem in every part of it.
Welcome to fashion. Jerry was previously at Vogtentanz, by the way, so which is the TikTok company. So you're a tech entrepreneur before a fashion and fiber entrepreneur, weren't you?
Yeah.
So you have a relative perspective.
Yes, I think fashion is very difficult, so we need to be more confident
Welcome.
dealing with the problems.
Amen. Bruno, tell us a little bit more about what you guys are doing. I think it's fair to say that you're probably the newest solution for everyone in the audience, turning CO2 into MEG. So tell us, MEG being a building block of polyester, tell us about how you're doing that and why CO2 as a feedstock.
There is obviously another supply of CO2, so it's a very convenient feedstock for us. Actually, our technology is an answer to the fact that there is too much CO2 on the planet, too much CO2 emissions. So it doesn't mean we don't have decision to make about the feedstock, because CO2 is a very large field. There is very strong differences between industrial waste CO2, biomass CO2, direct air capture CO2 in terms of carbon credits accounting, for instance. So all of that is some kind of mathematical analysis that you need to perform to have an end product that makes sense economically. In terms of technology, it might seem weird that we start from a gas and end with a liquid, ethylene glycol, that is then polymerized into a solid polyester chips that is then transformed into yarns. So the first step of the process, and I will try to be quite fast about the technology, is the transformation between CO2 and CO, CO being carbon monoxide. Why we do this? Because carbon monoxide is way more reactive than CO2. CO2 is very stable, and that's one of the main problems. So we have to cut the link to transform it into CO, then we can apply chemical reactions to it. Then we apply the carbonylation and hydrogenation to the products to end with ethylene glycol. So basically, we need CO2 and hydrogen and of course energy to create ethylene glycol that at the end has a carbon negative footprint. Then, as you were mentioning, we need to add another monomer, terephthalic acid, and the field of terephthalic acid is very large and it impacts the end product, polyester. So it's also strong assumptions that we have to make when we create the ideal business case.
Okay, can you maybe give us a little bit more of an explanation as to how taking the CO2 from industrial processes, from our atmosphere when we need to get rid of it, into carbon monoxide, and then turning that into the monoethylene glycol, MEG. So how significant is that? Because that's one of two processes that then result in polyester. So how significant is the capturing of the CO2 there? Sort of what are we talking about in terms of comparing that to just using carbon from waste food?
So you mean
carbon and oxygen from waste food?
What's the advantage of using industrial waste CO2 compared to other source of carbon?
Yeah, like how should we understand this? Because we've got other solutions here that are making polyester using other waste streams. I understand that carbon emissions are a waste stream or a byproduct, let's say, and we do need to get rid of them. But is it a good area to focus on? What makes it sort of viable?
Okay, so basically, if we start from the CO2 emissions from industries, at the moment the technology to capture it are very advanced, so they're actually able to capture the CO2 they're emitting. Problem is that in Europe, for instance, the main way of dealing with it is sequestration. So to put it very quickly, they capture the CO2, they purify it, it costs a lot of money, then they send it into $1 billion pipeline to the North Sea to dig it into the sea. So we try to find a solution that could actually make more sense. Lots of CO2 emissions are actually used for sustainable aviation fuels as well. That's the main areas of use of CO2. And it basically replies also, if we're not talking about fashion, an industry the industry of the strong CO2 emitters need, because, for instance, if you do cement, you can electrify the way you do cement. There's no problem. There will always be 40% of CO2 emitted.
Right.
So it won't disappear. They need to deal with it, and utilization is growing on that.
So what you're saying is, as much as we would hope to decarbonize every sector and not have an emissions problem, we're going to have an emissions problem for the foreseeable in at least a few sectors.
Yeah, it's not going to disappear. The idea obviously is to reduce it, and electrification is a way to do that. But when you work around like cement, steel, glass, they will always produce CO2. There is no way you can do glass without producing CO2.
Okay.
It's possible.
Now that we've had the chance to talk a little bit about your feedstocks and your processes and why you've chosen those, might be good to get into a customer specific discussion and hear a little bit about how brands and other customers that each of you work with are responding to what you're doing, and understand some of the challenges or the opportunities, or perhaps just the perception. Do you want to get us started?
Sure. Yeah, by the way, it's really weird, Brooke, isn't it? Seeing everybody flashing away, and it's like being in a day disco or something, isn't it? But maybe that's just my age. But
like
anyway.
silent rave. I want a headset.
I feel like we're missing out a little bit, not being in. They look like they're having a good time.
They do. I know. You guys are the cool ones.
So sorry about that. But yeah, probably just. So we've made this at scale. We're also learning from the first iteration that we had, which was corn, and moving to sugarcane. So perhaps just talk about some of the differences that our customers really appreciate about the new feedstock, and then also some of the challenges. And Jerry's very graciously also already talked about price, which clearly is one of the challenges. But first and foremost, there are other bio-based elastanes which is great. The more people talking about bio-based offerings, the better for the industry. So that's really good. I think what customers really appreciate about our move to sugarcane, there are three things effectively. One, it's a more sustainable feedstock. Two, everything's together, it's integrated, which means much faster speed to market. And number three, what that means is, of course, lower carbon emissions. And because we want to support the industry's adoption of these products at scale, we are really offering a very competitive price for that product. So those are kind of the three main benefits. More sustainable because lots of reasons why. One of the main benefits of sugarcane is you need one less step in the processing to actually make bio-BDO than you do other plant-based materials. So again, that's helping to lower carbon emissions. Putting everything together also makes a resilient supply chain. You know, we're all living through this complex, scary world going on. So putting things together. Also, you know, given the recent, you know, difficult things happening in the world around oil, you know, moving to bio-based over time is another potential benefit for the industry. So there are a number of really good things that customers appreciate. Not easy, it takes education that we've spoken about, but those are some of the key things that are coming back in terms of the benefits. Some of the challenges, definitely also, it's not easy, otherwise we'd all be doing it. And I mean, you've written very well about this and others, you know, I was reading Christine's Goulet's report on biosynthetics recently, and actually what that report was saying was very similar to what we're finding as kind of the three things that customers are asking. You know, one, first and foremost is, does it work? It's got to work in the same way. You know, we're making this at scale, but if it doesn't have the same stretch and recovery properties, I'm just not going to buy it, no matter of beautiful presentations and all this kind of stuff. It has to work in the same way that standard elastane does. So that's number one. Number two or three varies depending on the customer, but sometimes two is, what does it look like? You know, how does it feel? What is, you know, okay, it functions well, but what impact does it have on the garment? And again, has to perform in the same way. And number three, of course, or number two, depending on the customer, is price. How much is it? Well, again, we're being very frank, you know, we've just invested $1 billion to make this plant.
That was $1 billion, guys.
$1 billion, it's, you know, not a small amount of money. We've, like the esteemed panel up here, we really thought about a new value chain. So there are so many different things working with the farmers all the way through to brands and retailers, so many new things around that, you know, of course there's going to be an increment to standard elastane, but really, you know, again, we've done our best to kind of support the industry's adoption. We're really trying to price that to be super competitive. So price is, you know, we're not going to, you know, shy away from it. It's an important part of the discussion.
Can I ask you a quick question? So it just occurred to me that elastane is usually a minority fibre in a product.
Correct.
You know, it may be that a brand is buying large quantities across their product ranges, but it's sort of not necessarily the priority for product teams. You know, it maybe hovers around 2 to 5%. Is that an issue? Getting it sort of up the list of priorities?
Yeah, it's a really good question, and often what we're finding very briefly is customers kind of go on a bit of a journey. They'll think about cotton and polyester and man-made cellulosics, then maybe nylon, and then they look at elastane and go, oh, we don't buy very much of that compared to the other things. Ooh, but we use it across so many things. So coming back to the pricing thing, which is important for everybody, is, you know, what we're seeing now is customers, there's more flexibility from our brand and retail customers around how to think about the pricing for the product. You know, again, these problems are too big for any one of us to do on our own, so it does take collaboration to do this. And we're certainly seeing more flexibility through the value chain, whether that's a brand saying, I'm making it up, not necessarily that we're doing this, but we'll pay a license fee and therefore the mill can buy at the standard price, or we'll buy directly from you and share. So there's a lot more flexibility.
If there's a direct relationship in procurement rather than via tier one, for example.
Correct, yes. And more to your point, because people realize that probably thinking about elastane now, and it's a challenge for them across lots, they have to focus on it. So there's a willingness to think more flexibly about how to do that.
Okay, new buying models. Gudrun, same question. What are customers saying? What did Balenciaga say? No, you don't have to tell us that. Just tell us more broadly. No names, just who.
So I want to start out with saying thank you to our customers, and I wouldn't call them customers. I would call them partners, because we're really on this journey together, and we couldn't do it without them. So it's really amazing to see. So for me, my job is done with the endless filament, right? That is my, yeah. But then the journey starts to turn it into this magical fabrics, right? And this is really the work of our customers. And this is really impressive. We have the same challenges. So I know we have to get better to work on the quality, on the consistency, right? So this is our job, on the performance. But we struggle with costs, and yeah, it's the same challenges I think we all have, right? But I'm super excited to see that there is excitement, there is the need, right? And also our customers or partners see the need, but also the end consumer is pushing for these new solutions. And we are here and we have a solution technically. We need to make it economically. And yeah, this is a really nice journey we are on.
I think that's reflective of introducing a new material to the market, isn't it? It's a bit different than using a different ingredient to make a monomer to then make a polymer that people already know and use.
So I would really invite every end consumer to take it, to use it, to adapt to it, right? To buy it.
Yeah. And Jerry, what are customers saying about Leaf Bio?
I think I just say challenge. I think our challenge is the combination of both Amsilk and cement. Firstly, we face the problem of cost of the supply chain, and secondly, PEF is also a new material. And when you are dealing with a new material, you need to have you need to establish a new value chain. You need to know how to spinning it, how to weaving it, how to dyeing it. And when you are going to market, the customer need to know what is the name of it. And when you are user of it, and the customer need to know what's the end of it. Is it degradable or it's recyclable? You need to answer all those questions. But luckily, in the last few years, we have dealing with most of it.
I guess also because your polymer is behaving slightly differently, there's a new education that you have to do around that. You have to explain those properties rather than it just being a drop-in.
Yes.
Yeah.
Yes. At the same time, the customer have an expectation you can behave the same as the normal, the original one. You have dealing with all the problems when the first time you made them. So
yeah, it's tricky. Yeah, I guess the question there is as well, at what point do you start talking to brands, because you obviously want to get feedback on what you're doing, but if you're still developing it, everything isn't going to be quite perfect yet. So I'm sure that's challenging.
So just like her said, for your early customers, they're not your customers, your partners. They help you to dealing with lots of problems.
Yeah,
you are fighting together.
And Bruno, what about you guys?
It actually resonates very well. We are improving. The thing is, when we are 30 at Fairbrics, we have 28 chemists, so they have no idea what's happening in the fashion world, and they are focusing on ethylene glycol. And I'm not sure any of the fashion companies here would be happy to receive 500 kg of ethylene glycol. So we need to transform that ethylene glycol into yarns that actually look like usable yarns. And it took us a bit of time to understand the supply chain, find the right partners, understand what is doable, so also to give reference points to the industry. And it was tricky because it's completely out of the scope of what we've been doing for the last 7 years. So it's basically, for us, the challenge is to transform the technology, the strength of the technology into something very touchable, like garments. And this is where we're improving, and it was very new for us. So
it must be very difficult, though, in the sense that you're trying to have a conversation that petrochemical companies in the past have never tried to have. They've been providing the same monomer to other petrochemical companies who then turned it into a polymer, and then it's, you know, then sold as a yarn or as a fiber. There's no way anyone that many steps removed would have tried to talk to a brand in years past. So it's really the emissions capture and processing side of it that gives you the story to tell to the brands? Is that how you're approaching it?
Yes, definitely. Obviously, the fact that we have exactly the same versatility and applications than virgin polyester from fossil resources is a very strong point for them, because some of the application of polyester cannot be reached with the recycled polyester at this stage, and they're also looking for an alternative solution for the future when they won't be able to recycle all the polyester owners, or at least the resources of polyester won't be only recycled. So that's one of the selling points we have.
Right.
And for this part as well, the fact that our feedstock is super strong, unfortunately, is a strong selling point. Because, for instance, what happened with Hormuz lately was a bit of, created a bit of fear in the industry, because like some people didn't have access to fossil resources anymore to do MEG, for instance. So they're thinking like, okay, maybe we should consider that for the future.
Irony, Bruno, the irony. We can't get the oil, but the emissions are still flowing. It's like, yeah, fossil, but in the wrong place at the wrong time. I'm going to jump to questions early because I feel like we've covered an immense amount already, and I think it would be good for us to give the audience an opportunity to have an extra 4 or so minutes to ask questions. I'm just going to consult the iPad now and see which questions have come through already. Okay, we have quite a few. Ooh. Okay, first one. This is for you, Simon. Are you actively sourcing your sugarcane feedstocks from either ethical or fair trade growers?
Yeah. It's the most important thing when we're kind of pioneering the use of sugarcane in textiles in this way. So there are some really interesting existing structures from other industries that we are looking to use as scaffolding in this new area. But again, we don't have all the answers, Brooke. We're working with partners. So we continue to look at lots of different certifications, ISCC, RSB, Bonsucro. We're very happy to have sourced our sugar through Zarnico and their Vive verification program, which is actually used in the food and beverage industry where they're sourcing a lot of the sugar came from. So again, as our knowledge and understanding gets better, that will improve. We're also working with Textile Exchange and the industry to think about how the industry certifies, talks about bio-based in this, bio-based synthetic. So short answer is yes. Long answer is it's an ongoing process, but we're very happy with where we are. We're also working with a number of, or one traceability platform. So by the end of the year, in terms of fiber traceability, we'll also be announcing a collaboration with that partner as well. So we'll have full traceability.
Okay, excellent. We've got so many questions here. One person has said, if we fully transition, will there still be enough sugar feedstock? Yes, you answered this and said that there's a surplus because fortunately we're all starting to eat healthier. We don't eat as much refined sugar anymore. Okay, with new research coming out about chemicals in textiles, will any of the new solutions for synthetics be 100% chemical free? Well, chemical, that's a tough one because everything's chemicals. CO2's chemicals, H2O's chemicals. So it's not really about chemicals, it's about toxicity and about what happens in the environment when that material is errant. So I'm not sure we can answer that one now, but maybe if you come up to us afterwards, maybe we can get into it. What barrier is stopping the use of more biosynthetic fibres? Is it cost? And if so, will eco-modulation help in Europe? Thoughts, anyone? Gudrun, you said that you're fiercely Europe-based. Tell us, what role does all of this play?
So cost is definitely a tough one, I have to say. Sure, we are working with the European Union to help us, and I think it's the right way to go, and I think it's really important that Europe is investing in biotechnology and get stronger or stay strong in that area. So but cost is definitely
and the rules, we need clear rules,
Yes,
right? We don't know what
yeah.
eco-modulation will actually entail. We don't have the delegated acts for DPP yet. It's frustrating,
Yeah,
but
you're right.
yeah. Okay, thank you. Bruno, question for you. Could the biogen CO2 that is already produced by the biomethane process, could that be used, or is it related? Tell us more.
It's actually one of the main source of CO2 that we could use. The nice thing about it is that it's very, very pure. It's the main market for this CO2 is sparkling water and beers. So when you drink a beer, it's probably made from that CO2. It's a bit disgusting, but it's very pure. So yeah, we can use it. So one of the problem is related to regulations around that, because it's considered a product. So in terms of carbon credit, it's not exactly the same as industrial waste. So we use it, we did a lot of tests with it. It can be used, but then it's a mathematical analysis of the economic side of things to know if this is the right path.
Okay. Thank you. And I guess anyone who wants to chime in on this one, how do the chemical hazard assessments of these products compare to the incumbent products in the market? I guess, again, that's about processing. Which chemistries are you using? How compliant are those? But anything to add, anyone, about your differences in output in terms of chemical hazards? Maybe even in the processing, that, you know, there's a mixture of chemical and biological processes here which have lower footprints. Anything that you guys could point to?
Maybe just very briefly for us, you know, it's really important. This is a drop-in solution. You know, BioBDO is we're just changing the feedstock of BDO. We're not changing, you know, the chemical composition of it. So really, that's been critical for us. So we follow the many certifications and compliance that we have to do in our own plant, and we're just changing the feedstock for BDO. So we're not changing anything else around that, if that makes sense.
Yep. There's a question here about brands. How can all of these solutions become more economically viable? We definitely can't just have them in luxury products. I mean, elastane's a fairly democratic material, ordinarily speaking. You said you're offering price parity, but I mean, that's a concession, I assume.
Yeah, not quite price parity. Depends who you're comparing against.
Okay.
But competitive pricing, definitely.
Okay.
And again, I think there's no simple answer, Brooke, otherwise everybody would be doing it.
Yeah.
You know, we as innovators can't keep innovating if we're of course not getting the return on that investment.
Yeah.
Over time things change, of course, but again, what we're seeing is, one, we want to help the industry adopt at scale, so we are pricing this very competitively, and as I mentioned, we're seeing a lot more flexibility across the value chain about how to make these things work.
Yeah.
And for elastane, as you say, it's such a small component generally of the overall garment, so the actual impact in the finished garment price is really small.
Yeah.
But then you have the challenge of, you know, how do you market that, and brands and retailers thinking about green hushing and all these kind of things. So that's another discussion.
Another challenge.
Yeah.
Jerry, what about for you? Do you see your novel polyester going into everyday products? Who are your target brands? You know, you've already mentioned price at the input stage. How is that influencing price at the output stage, and will we all be able to afford it? Sorry, too many questions in one. Do you see your output as something that's going to be, I mean, obviously you want to achieve commercial scale, but how affordable will it be compared to the polyesters we already have?
I think it's depends on two things. First thing is something about scale. For now, we are production line of 15,000, and we plan to get a bigger factory. But as you know, the factory unit of polyester is around 1 million ton per year for the smallest new one. So when we scale to this level, I think the cost is almost the same. But we have another choice, because as you know, our material is recyclable. So for our customer, when they use for the first time, it's expensive. But when they recycling it, use the similar technology to as polyester recycling to recycle it, the recycling cost is almost the same.
Right.
So it's affordable.
Okay, got it. Sadly, we're out of time. It was such a great panel. I guess for anyone who didn't have their question asked, please come up and say hi afterwards and ask your questions. I want to say thank you to whoever sent the moderator comment. I appreciate that. And thank you finally to all of the panelists today for a great discussion, and enjoy, everyone.